Hello friend, welcome to plastic product design series. So let's discuss the remaining questions on runner system in the injection molding. So first one is why the runner tapering is important in the runner design. So if the runner is long, okay, so at that time from sprue to the gate we need to taper the runners to maintain the proper flow in the runner system. So for that purpose we need to reducing the diameter from a sprue to the gate. What is the purpose of a runner ejector system? So the ejector systems is actually used to eject the part from the mold. Okay, so we need there are the different ejector pins are there. So number of ejector pins are there. We need to they will push this part and we can eject the part then. Okay, so how can simulation software help in the runner system design? So simulation software actually very important to check the flow and how the cavities are filling, and how the temperatures are at the each stage. We can track the material at different stages. So for that purpose actually simulation softwares are very helpful. So before going to build the actual mold or to manufacture the actual part and the mold, so we can go with the simulation so that we can easily understand the flow and how the cavities are filling, and based on that, if we feel that there will be the modification needed, so we can directly modify and change the design. Okay, so simulation software is very important because for the actual mold and the actual part there will be the more cost. So modification we need the more cost. So just go with the simulation perform, and after that we can go with the actual mold manufacturing and the product manufacturing. What is the ideal runner shape for the high flow efficiency? So generally for high flow efficiency full round runner shape is used. So and this full round is split into two halves, like the first mold and in the second mold. So here for in the full round runner shape actually will get the good flow. How do you calculate the runner volume and why it is important? So generally the runner volume is calculated like cross sectional area into runner length. So we'll get the runner volume, but for the runner volume we can calculate in the mold design software also, where we can get the exact runner volume. So this one is a very important runner volume because we can track the how much material is wasting, because in the cold runner systems we are cooling the runner also and we are ejecting the runner also. So at that time we can track that the how much material is the wastage is there. So for that purpose runner volume calculation is very important. What are the effects of undersized runner on the part? So if the runner is undersized, so at that time there will be the challenges of the material flow. So we need to properly choose the runner size, like we can't choose the undersize or oversize. So proper runner size we need to choose to get the proper flow of the material into the runner system. So what are the advantage of trapezoidal runner over the rectangular runner? So you can see this one is a trapezoidal and this one is a rectangular shape runner. So trapezoidal runner has the better flow characteristic than the rectangular runner due to the due to its more efficient cross sectional area. Why is the gate location critical in the runner design? So gate location is very important in the mold. So we need to properly choose the gate location based on the part complexity, the part geometry and the size of the part. Okay, so because if we choose the random locations or improper locations, so at that time there will be the chances of like a flow mark weld line and the voids defects. Okay, so we need to properly choose the gate location so that the material distribute uniformly throughout the cavity. What are the typical runner diameter for the small and the large part? So generally for a small part 2 mm to 6 mm, and for large part 6 mm to 12 mm or more than 12 mm. So the runner diameter is actually depends on the material, part thickness, part size, part geometry, complexity. So depends on that we need to choose the runner diameter. What is the purpose of cold sunk well in the runner system? So you can see this one is the cold sunk well, the extra depth, or this you can see this one is a trapped area. So from the sprue the material is coming like this. So here, so at the tip, so this material is actually solidifying, at the premature solidification is happening here. So this solidified plastics we are trapping here. So this one is in the cold sunk well. So we are trapping here because if this solidified plastic goes into the cavity, so at that time there will be no uniform cooling. So for that purpose we are trapping that solidified plastics so that the uniform cooling in the all the cavity. Can hot runner improve the part quality? Yes, in the hot runner systems actually improves the part quality because we are keeping the material in a hot molten condition, because here we are using the hot runner and keeping the molten plastics in the for the each stage. So in every cycles we are directly injecting the molten plastics into the cavity. So there will be no no like a removal of the runners and cooling of the runners. Okay, so there will be no wastage, and also this hot runner system improves the quality. What are the main drawback of using the cold runner system in the complex part? So generally these cold runner systems are used for a simple and single mold type of in single mold and for simple part. But for complex part, if you use the cold runner system, then it will lead to material wastage, longer cycle time, and difficulty in balancing the flow to multiple cavity. So friend, I hope you got some new information on the runner systems. So this video is for your practice purpose or for revision purpose. So thank you for watching. So in the next, from the next video we will discuss the gate types of gates and the design guidelines, and the also we will perform the revision in the multiple choice questions also in question and answer format. So I hope you like this video and stay connected. Thank you for watching this video. See you in the next video.